Okay, everyone, we're going to start this November Soil Network of Knowledge webinar, and welcome everyone. I'm going to get on to introducing Sally McGuinness-Clark, who's from Office of Environment and Heritage, where she's worked as a soil scientist for over 20 years. Sally's background is in soil and landscape assessment, soil survey, soil monitoring and soil health. In addition to this, she currently manages the New South Wales Soils Knowledge Network, which is a group of retired citizen scientists, and that group aims to promote the importance of soils through knowledge and expertise. And we've actually had a few of those members present really fantastic webinars for us. So they have a Facebook page and a web page stuff, so it's good to look into that if you're interested. So today's webinar, After the Fire, is an ongoing project on soil loss recovery in the Warrumbungles National Park, and that draws on Sally's specialist skills as a member of the New South Wales and ACT Burned Area Assessment Team. And they're looking at the post-fire soil and hydrology risk assessment in the park. And that's what Sally's going to talk to you about today.
Okay, good morning everybody. I'd like to begin by thanking Abby and Luke for inviting me to give you this presentation this morning. And I hope that this presentation that you're going to see here today covers everything I hoped it would, and that you all get something useful out of it. Okay, so we'll begin. So as Abby said, this type is titled After the Fire in the Warrumbungles National Park, New South Wales, an ongoing project in long-term soil loss and recovery. Okay, this project is important because the lessons that we learn here will have a direct impact on the recovery program in the Warrumbungles. They have broad application for recent impacts and post-fire monitoring of wildfires, and also in the management of hazard reduction burns. I'll also like to acknowledge the contribution of several people which have contributed to this project. That includes Mitch Chulo, Robin McAlpine, Charlie Carruthers, Shiwa Yang and Boffa Yu, and of course, you know, everybody in the Burned Area Assessment Team, because those that are here will notice some of the photos are familiar. So the purpose of this talk is to tell you particularly about this project, which is one of only several post-fire recovery projects which are currently ongoing in the Warrumbungles. Over the next 20 minutes or so, we'll cover a bit about the fire, the rain event which happened, what I'm doing with soil monitoring, fluvial monitoring, erosion modelling, too many monitorings, and then I will finish up with what are our impressions so far, but also that they're not conclusions because, as I said earlier, this project is still ongoing. So, background for the fire is that on the 12th of January 2013, a fire began in Warrumbungles National Park. In one day, it extended over 39,000 hectares in extreme fire weather. It destroyed 53 houses and a wide variety of other assets. The fire was contained at 56,290 hectares, 22,000 of which were actually in the park. And the important thing here is that 76% of that fire was at high to extreme burn severity. This slide here is just to give you an idea of the location we're talking about. The study area is in northwest New South Wales, and Warrumbungles National Park is just west of the township of Coonabarabran. The burn area was over 56,000 hectares. That small map in the right-hand corner up here is just to give you an idea of what that burn area, how big 56,000 hectares is actually, and what that would look like if it was actually laid up over the map of Sydney. These images here, which you can see here, are just a variety of images from the fire. This one on the top right here is actually was a pretty famous photo. It's actually taken by a commercial airline pilot flying over the burn area. This one to the left, you know, just indicating some of the outbuildings around Siding Springs, which is of course the astronomy station. And the bottom two are some photos from the burn area itself. This one here was something taken from a 7 News helicopter showing you, you know, can you imagine standing there at this thing at the edge here looking at this fire coming? this is just, you know, extraordinary. The burn, the fire was so intense. This photo is actually a very typical one of what it looked like afterwards. There were places in the park where there was 100% consumption of fuel. And you can see here that it's pretty intense. There's nothing left on the litter, and although there are still some finer fuels left on this one, it's pretty typical. The other point to note here with this photo is actually the absence of the erosion. This photo was taken about 2 weeks after the fire began. The fire was actually still, you know, still going in some places of the park, but in the days immediately after the fire, and the next sort of 10 days, there around 20 to 30 millimetres of rain did fall on this landscape. And yet if you have a look, there's actually no erosion. This is a copy of the burn severity map. This is actually the original burn severity map. It's been updated since this. The yellow line is the park boundary. And looking at the statistics on the right-hand side there, yeah, that 70% of the burn was high to extreme. So that's the black and the red areas. And if you notice how concentrated they are in the centre part of the park. And then in the afternoon of the 1st of February, approximately 100 to 125 millimetres of rain fell over the park in an area, a time of less than 40 minutes. The Bureau of Meteorology data from the nearby weather stations didn't record anything like that amount of rain. In the top left corner, there is a copy of the radar from the bomb station. And if you actually have a look here, the Warrumbungles, this little black area up the top here, that's where the bungles are here, and that's where we're talking about. So there is also a rain gauge at the Strathmore depot, which is actually just down this road here, down to the right there. We base our estimate of 100, 125 mils on that rain gauge, but no matter how you look at it, it's a lot of rain, and it's actually an enormous amount of rain, and it fell on a vulnerable landscape. So all that rain basically led to runoff, and huge amounts of runoff, as you can see here. And I should mention that these photos taken here were taken by Dave Brill, a National Parks officer in the Coonabarabran office. So he's taken all these these immediate photos are actually Dave Brill's photos. There's some more runoff for you. A landscape that just doesn't cope with all that rain, and it all had to go somewhere. So that much runoff leads to flooding, and there was some intense flash flooding that happened around the depot. That's actually the depot. In the right hand, this is actually the rain gauge that we're talking about here. Yeah. So the next slide. This is behind the depot. That image there contains a picture of a shipping container. Now that was actually a fully loaded shipping container. It actually contained, I believe, helicopter fuel. So that gives you some idea of the energy in the water there. So all that water led to some erosion, which was not a surprise. This is actually a photo of the Warrumbungles Creek just on John Renshaw Drive near the middle of the park. This photo here, we can see that the floodwaters actually came to just below the road here, stripped along here, and the energy actually ripped off the concrete support under the road here, so stripped it off here. This photo down here at the bottom left here is Mitch Chulo took this photo. It comes from about 15 kilometres downstream on the western boundary, past the western boundary of the park, and there is a flood marker here. We can see it up here, and that measures at about it hit 3.47 metres, which is a significant flow. This is another photo by Mitch. It clearly shows some of the scorch marks from the fire, and then you can see, which is along here, and then there's this fresh exposed rock which happened after the rain. So this is, in 40 minutes, this is the sort of erosion that happened on this site here. And if we think about average soil bulk density, 1 centimetre of soil loss across that area is going to the equivalent of 165 tonnes per hectare of erosion. In this photo here, using the ruler, we can see that the soil loss ranges from about 3 to 6 centimetres on this rock, which is in the range of 495 to 990 tonnes per hectare per year, which is, anyway you look at it, pretty close to apocalyptic levels of erosion. So all that material, if it's left the slopes, it had to go somewhere, and it built up in the lower parts of the landscape. This is just a foot slope near what used to be the old visitor centre, and there's over 1 metre of material that's been deposited above the original soil layer there. Another consequence of that of the rain was that first order streams were scoured to bedrock, and the lower levels of those streams then commonly contained debris flows, particularly in the areas of the sandstone country which are underneath the volcanic areas. The Burned Area Assessment Team made a series of recommendations after the risk assessment, and that their recommendations were that there would be increased frequency and intensity of runoff in all areas until the vegetation in the park recovers. That the sandstone areas below volcanic upper slopes were at the greatest risk of sheet and gully erosion, and particular hazards occurred where drainage lines and roads cut across these areas. And both of those things have seemed to be true. The other point that they made was that the fire and the subsequent severe rain was a massive event, and the result led to extraordinary soil erosion, landscape change, and long-term damage to infrastructure and soil resources. Okay, so moving on to, that's the background for what happened with the fire and the rain, so moving on to the recovery and what we're doing out here. We've divided our project up into 3 approaches. The first thing is to look at closed soil erosion monitoring plots, and which actually collect real soil loss data, which is quite an old-fashioned approach to take these days. Most people do a lot of modelling, so we're actually collecting data. We're actually monitoring the bed level change in the creeks which drain into the area around Blackman's camping ground and the temporary visitor centre. This was at the request of the National Park staff. They were really concerned about access into the catchment, as there was sedimentation which reduced over the creeks, there was flooding, so they want to know how long that's going to be an issue for them. The third part of the project is the modelling component, where we are doing comparison of post-fire remote sensing imagery before and after the rain event on the 1st of February, and then we'll be calibrating these images using real data from the soil monitoring plots. Then the next step will be to develop a time series for long-term soil loss and recovery. So we've established 12 plots. We stratified them based on burn severity and parent material. We reduced it to three burnt, unburnt, low to moderate, and high to extreme, and then we bulked the parent materials into sedimentary and volcanic. Unfortunately, 2 of the sites of the geology turned out to be not what we planned for, and then the burn severity map was updated from 4 classes to 8. So we've had a bit of a drift from our original stratification. But ultimately, I don't think it makes much difference, because we didn't have a lot of choice about where we were going to locate the plots. Access was severely reduced in the park. A lot of the burn areas were consistent in terms of severity, so we placed the sites where we could and tried to achieve the best spread that we could. This one here is just to show you, is it just a bit of a location of where our plots are, the 12 plots, and they're spread across the park. Coonabarabran to the east, and we've got sites, the first one here up at Siding Springs, we've got 2 down here in the Strathmore Valley, our highest site up here at the TV Tower, Gunnamaroo, our driest, wettest site, and then we've got another 6 up through the main Central Valley, and then the Northern Fire Trail. These shots just show you what some of our plots look like. The plot area was 8 metres squared. The slopes range from between 20 to 38%, with most sites are in the 20 to 28% slope range. Sediment erodes from the plots. It falls into the trough. You can see it with this trough down here. And then we collects in the box, and then we collect it, we dry it, we weigh it, and then use it to calculate tonnes per hectare per year. The rainfall. Now, the rainfall is a complex story and one which we are struggling with. It is extremely variable across the park, and it varies both in spatial distances and it varies in its intensity, and it presents the biggest challenge we're facing in this project. The little table at the bottom is just to show you, give an indication of what the diversity of the rain and the spread is like. That's just up from May last year until November 14, just those 3 periods there. The rainfall variability is enormous, as you can see. I mean, this is all, we know this is, we expect this because a lot of the bomb stations aren't actually right in the park. They might be close to it, but they might be on the surrounding plains. And with the terrain of a shield volcano being so different and so high above the surrounding plains, you've got to expect it to be different. On the positive side, we've developed good relationships with local landholders who are welcome to and willing to share and record their trove of valuable rainfall data with us. This table here is just to give you an indication, just to show you what cumulative erosion we've measured out there since June 14 till August this year. The colours represent the various sampling periods. What I want you to see here is that the wide range of sediment collected over a single period, highlighting that variability in the rainfall volumes and intensity, which I was just talking about. Some of these sites are quite close to each other. They're within a few hundred metres of each other. So for instance, plots 2 and plot 10 here, and plot 10. They're quite similar on similar parent materials and yet quite different erosion rates. Likewise, plot 7 and 8 are very close to each other, but yet very different trajectories. This table is the measured erosion rates which we've calculated for each of the plots, and from June 13 until August this year, the highest erosion is at site 12 with 29 tonnes per hectare per year down here. This site is on a sandy leptic tenosol with a low fire severity. So is it, did we expect this or not? The second site is at Gunnamaru. It's a red dermasol on rhyolite, which was unburnt, and yet look at the erosion coming off here. The third site, number 8, Scabion Hill, sedimentary conglomerate. It's a steeper slope, but it's a high burn severity. So what we can say about this erosion is that in the Warrumbungles erosion story is a complex thing, and what you expect to happen often isn't what does happen. The ground cover is changing at each site, and we are recording fractional cover, and we're using that to calibrate the remote sensing imagery, which will do that feedback back for us as well. Part of the project is the fluvial monitoring, which I mentioned earlier. We've got 68 fixed points where we measure relative changes in the height of the stream bed, and over time we're seeing changes in the sediment movement down the catchment. This is a graph of the middle branch of Buckley's Creek from June to August. So June the red line and August the blue line. You can overall there's a trend of bed lowering, which you can see. You can also see then how the shape of the bed is changing as well, and there are slugs of material which are moving down the slope. So this actually records we're recording plus or minus relative change. It's not the exact elevation we're talking about here. This is actually centimetres, not elevation. So the next step in this project is we're trying to get a differential GPS to accurately measure elevation, and we can identify residual terraces in the bank deposits of the channel, and then we can use the dimensions of the channel to estimate total volumes of sediment which have been transported in this catchment since the fire. We're doing stream cross-sections as well for the flume, which is looking at geomorphology and how that's changed. we've got 5 cross-sections across the Buckley's Creek subcatchment where we measure the height of the bed from a level string line between 2 fixed points. Again, the trend is a reduction in the height of the bed and the sediment catchment over time. Generally, it was reducing up here, and then we come along to August up here and then back down again. But it all depends on the rainfall and the intensity and how much movement we're getting. Okay, so the impressions, which are not conclusions so far, was that the enormous wildfire was a massive event. In terms of likelihood of this occurrence, it's been recorded as being a 1 in 10,000 year event for the erosion. The result was extraordinary soil erosion and landscape change. The second point so far, importantly, is that rainfall and therefore erosivity and the energy in the rain to cause erosion is thus far the dominant factor influencing erosion and recovery in the park. And it's vital that what we're doing with the rainfall, we can then fill in some of those data gaps. There's 9 months to go for this project, so we've got a lot of data and we're about, embarking on seriously crunching it and seeing where we're going. Which leads to the next point, which was that we missed it. The project began, the fire happened in January 13, the rain event in February. We didn't actually get money and authority to begin this project until May the following year. So there's 14 months there where we are trying to fill in that story. And the last point is that the data that we collect at the erosion plots and the fluvial sites will inform the modelling and the long-term erosion in the next stage of this project. So this wraps up this presentation. I hope that you have found this story about the way that fire and water movement through landscapes to be an interesting one. Our findings will help inform the recovery of the park and management and guide management into the future. Personally though, my participation in the burned area assessment team and then continuing in this post-fire monitoring has forever changed the way I feel about fire in the landscape. The force of fire and the scale of change can't be underestimated.
Thank you very much, Sally. That was fantastic and very sobering in terms of the numbers. On time. I'm very impressed. You get a gold star. Okay, so now we have time for questions.
Yeah, look, fantastic talk. Thanks, Sally. What hits me is events like these extreme events, the ones that actually form the landscape that we see, these sort of quite rare events. Are they the ones that really do leave the landscape the way we see it today?
Thanks, Luke. I think that what we do know for certain is that these sorts of scale events have happened before. There is plenty of evidence as you drive around the park of old debris flows, and once you get your eye in and you recognise what you're seeing, virtually every second drainage line contains an enormous debris flow. There are places in the landscape where whole creeks have been diverted by flows. It's just landscape change like this has happened. I mean, they're a long time coming, I guess, but we know that there's been so much erosion happening out there. In the visitor centre, if anyone's been out there, there's a map on the wall at the door which actually shows what the Warrumbungles used to look like, hundreds of millions of years ago, where it was the height of the landscape there was probably 2/3 of what it is now. And at the moment, the top of Siding Springs is about 1,100 metres. So imagine if it was about 3,000 metres, what that would have looked like. There are places too where there are alluvial gravels underneath a bit of volcanic material, a bit of trachyte at the highest point of the TV tower, which can only have been there by recognising that used to actually be the lowest point in the landscape. So the change out there over time has been enormous, and certainly there is a lot of carbon, there's a lot of charcoal in these debris flows. It's a project that Mitch wants to look at more, and we'll hopefully get a time to get on to that in the next couple of months by get some samples and sending them off to the lab and get some dates going, and then we'll have an understanding of the frequency of these sorts of events, and because we can see that they've definitely occurred. Does that answer the question?
Yeah, thank you.
Thank you. Also, Rebecca's got a question.
Well, thanks, Kelly. A really, really interesting talk. I'm just wondering, I guess it's hard to say because we don't have the data from immediately after the fire, but if they didn't have that massive storm, there still presumably would have been erosion because the soil was so vulnerable and uncovered from normal rainfall, would there?
Thanks, Rebecca. Yeah, well, look, yes, there would have been. You know, if you've got a landscape that has steep slopes and no cover and it rains,
yeah,
you know, there's going to be movement. I think the key to what I was trying to say earlier is that there was the fire happened on February, and there was 20 to 30 mils of rain, which was obviously light rain. It was gentle rain, and the landscape was so dry it just soaked it up like a sponge. So whilst on some of those photos I showed initially when you were looking at these landscapes saying, where is the erosion? I don't understand. Subsoil moisture was actually increasing, and then when that big event did hit, the soils were pre-saturated and ready to go. So they were heavier on the slopes, and when it took less, you know, when the rain came, they were off and running. You know, and to see so much soil washed away and leave the catchment and basically, well, you know, it's gone to Gilgandra now, but, you know, that trend has been happening for, you know, millions of years. That's why the plains are like that. That's why the mountain's only a third of its height. Yeah.
I'm wondering, in your soil plots, the impact of vegetation returning on erosion rates versus, obviously you've got some very rocky areas that don't look like they've got a lot of vegetation potential. Have you got any interesting figures on that at all?
Yeah, we do. Every time we go out, I couldn't cover everything when I was in my 20 minutes. We do measure ground cover every single time. We take photos of the landscape every time we visit, we usually time our visits based around when there's been a bit of rain. So we do have a series of photos showing how ground cover is changing at each of the sites, and in some of them it's changing quite dramatically, and others less so. Of course, there's, you know, the succession of the vegetation is the interesting thing as well. You know, initially there's basically just rock and a few baby acacias sticking up, and you come back 6 months later and the acacias are 3 metres tall and you can't find the plot. We're wandering around going, where is the plot? It's here somewhere. So there is the changes that are happening, and they're all different. Each site, it's different things are happening at different times. So I think there's ground cover certainly plays a role. In terms of growing ground cover, I should clarify too, because of course that provides rainfall interception, stem flow, which moves into the ground, as opposed to rain that falls on bare soil, rain splash impact, which is like that bomb going off. And rain splash impact, we've seen, is a significant factor for a lot of these soils. When you get there, the tray, which at the bottom of the trough is, you know, just covered in dust and rain splash. So I think the story isn't finished with ground cover, because one of the sites that I named that has some of the worst erosion at Gunnamaru, which is the unburnt site, has no green material, but actually has a lot of litter all over it. You know, sort of in the 80–90% of litter, but only 5% green cover. That's actually growing, and other sites that seem to be doing so well. It's a complex thing, and we're talking to some of the plant people doing the plant monitoring to come out and have a look at us and see what they think might be going on. But, you know, possibly it's related to springs and water flow, subsurface, position, landscape. But at this stage, yeah, I haven't got a trend for you to show, only that we've got a lot of data and it's tricky.
Thank you.
Thank you for the question, Rebecca. Sally, I've got a question here from Stephanie Alt, who doesn't have a microphone, so I will ask her question. She's interested in what she says here is the development of the newly exposed soil surface and biological activity. So she says presumably the more biologically active topsoil layer has largely been lost in the soil erosion events, and is there any monitoring of that soil biology in the topsoil, and if so, is it recovering?
Okay, good question. I'd agree that if we lost 1 to 5 centimetres of the surface soil pretty much across the national park and the whole burn area, that it was the biodiversity that would have been lost was extraordinary. That said, there are we aren't specifically monitoring biological stuff other than the ground cover, and in that we're monitoring cryptogams. So we're just seeing how many, what percentage of the ground cover is green grass, is dead litter, is a cryptogam, or is a rock, as a protection for the soil surface. But that's not my expertise, is the biodiversity stuff. But it certainly would have made significant changes. But yeah, we aren't monitoring it at this point.
Okay, thank you. It'd be interesting to know if the National Parks is looking into that too.
Yeah, I don't think they are.
Okay.
I mean, they're looking. The other monitoring programs are, so there's the water stuff, and there'll be there's biodiversity issues associated with the water and the water quality. There's fauna people, there's flora people, there's I think there's about 20 different projects all going on up there. The one person that might know something about that is Yoshi, who is monitoring sediment cores and looking at algae and pollen from Crater Lake, which is in sort of this high elevation ephemeral lake in the top of the park, and he might had something to say about that.
Thank you. I would like to take the opportunity to thank Sally for that presentation. It was really very interesting, and all of you also for participating today. And Sally's email is there on that slide at the end, so everyone can see that, and her phone numbers. So if something occurs to you or you have another query a bit later on, then you could do that. And please feel free to forward your invitations on to anyone who you think might be interested for any of the webinars that you receive an invitation for. So thank you very much.
Okay, thank you, Abby.